Good afternoon, everyone. So yeah, I'm Gurudutt from Nokia. So the topic for today is assembling AI pipelines with Acumos. I think this topic is correlated with various talks today. Earlier I think during Kazi's presentation, he talked about pipelines and how to use uh, the design studio to compose. Okay, thank you. He talked about considering different pipelines while composing your multiple models in your studio. Then again, during the panel talk, there was discussion about how in the future releases they're going to talk about Acumos is going to look at accommodating or looking at different kinds of data pipelines. So I think this is a very relevant talk, and also I think in the previous two talks, very interesting talks both from Augury and the somatics. For example, in the last talk, he mentioned about all these different complexities that you have to consider when you're coming up with your the model that is going to be deployed. So I think this is very relevant to multiple talks. So with that, let me get started. Okay, I just want to start off with this slide. Just take a step back. So this is one of the first steamboats. Do you see what is something that is very evident with this picture? It's a steamboat, but what do you actually see? You see masts. So what was the thinking that time? And so this is like a nautical analogy with where we are with AI networks today, right? So we had the steamboat, but the trust and confidence was not yet established. So you wanted some kind of a fallback proven approach. And the ideal situation is, so you wanted to try out the steamboat, but if that did not work out, you still had all your proven approaches. So that's like your masts. And the ideal situation is like you want to augment the sail power with your steamboat, right? And I think that's where we are with AI today in networks. We're not trying to replace everything, but we want to augment what we are doing with AI approaches. Okay, so this is, and I think Acumos, right, is a big step forward in this direction in getting AI into networks. There are a lot of proven approaches in networks, but we want to augment networks with AI. So it is a really big step forward because I think it provides a marketplace for innovation. Where you can share models, improve on models, and so on. So I just put here the high level view again of the 4 steps. You have the create and onboarding. Let me just figure this out again. Yeah, you have the creating and onboarding step, followed by the training, and then you do the publishing, and then you do the final deployment. What I want to focus in my talk is really on steps 2 and 4, because steps 2 and 4 are actually extremely involved. They're not as simple as they look here. Okay, so I'm really going to zoom into steps 2 and 4. So let me go to the next slide. So when we talk about training a model, it's really a tiny fraction of everything that you need to think about. Oops. Tiny fraction of everything that you think about. So your model is really a very small portion of what you need to think about. So what you see here are 2 columns of different components. The left side are kind of general stuff that you always think about. What kind of hardware do I want to run it on? What kind of an operating system am I going to use? What kind of storage? What is the framework that I'm going to use for my machine learning models? And on the right side are the components that are more specialized. What kind of user experience do I want to have? What kind of a network topology should I consider so that my user experience is enhanced? What is my target? Is it like an SoC, a GPU, a CPU, and so on, right? So there are all these different aspects that you do need to think about before you come up with an AI application that you want to serve. Okay, so I want to now look at 3 different use cases just to give you a better insight into the complexities that are involved with different use cases. So here is a use case where you have thousands of radio access network sites deployed in New York City, right? That's the situation today. Now, in each site, So for these sites, right, in each site, your cloud is actually is either embedded in your base stations, or it is on some racks, your edge cloud. And what you generally want to do is, for each site, you may want to deploy multiple machine learning models. For example, you may want to have one machine learning model which will predict the best beam direction for a given user that is walking on a street. You may need another model. So this particular model may be deployed on a system on chip. You may have another machine learning model where you are trying to decide what kind of time and bandwidth resources you want to assign to a user with the goal of maximizing your system capacity. That is computationally very intensive, so you may want to deploy it on a GPU. So at a given site, you may have multiple machine learning models that you want to deploy, and you really want to be sure when you deploy these models that they don't mess up the network, right? Because this is extremely critical, so you got to be very cautious. So this is one use case. Another use case is video analytics. So here is a case where you have a camera, an outdoor camera which just costs $20. You want to do video analytics on the stream that you're getting from this camera. Now you need to decide, do I want to store this video in the cloud, do the analytics, and then stream it back? If you want to do that, the cost of storing your data with just this camera, single 720 pixel camera at 25 frames per second, is going to cost you close to $4,000. Or is it better to consider your device itself to have some kind of an hardware accelerator, so that instead of storing all this data, your device itself can do the video analytics on the fly, right? So this is something, again, that you need to consider. A third use case is that of augmented reality. So what you're really trying to do here is you are viewing a virtual object, and you want details about the virtual object in the field of view to be downloaded. You want more information about the virtual object. And to be able to download this information, you could consider two different network topologies, right? You have the one on the left where all of this data is stored in the cloud, and then the one on the right where you actually have an edge cloud. If you look at the one on the left, the problem is that you're going to have a large time lag, a lot of latency, right? So you need to, it's very important to have an edge cloud that is close to the user device, so as to reduce the time lag. So this is another use case where now you're looking where network topology now starts becoming critical. So different use cases, you'll have different priorities on what, you will need to prioritize, different components of all those different components on, that you want to focus on. Okay, so that hopefully gave you a glimpse of why you need to look at all the different complexities and how it differs for different use cases. The next thing we want to look at I want to go through is AI pipelines. I'm sorry, the architecture that you need to consider. So there are actually two different viewpoints. There is an existing viewpoint, which is mostly done today. You have all of your infrastructure in the enterprise. And all you're doing is, when you run out of resources so your control plane is in your enterprise infrastructure. And when you run out of resources, you use the public cloud just as an extension. Another viewpoint would be an inverted pyramid of this, where your control plane where your public cloud now becomes your foundation architecture. Your control plane is in the public cloud, and all you're doing is you're going to reach out into your enterprise infrastructure to access data and devices that you cannot put on the cloud. Now, why would you want to do this? The reason is that it takes a lot of investment time to develop a very agile and resilient architecture inside your enterprise today. You can easily depend on public cloud providers such as AWS or Azure to provide you the resiliency and scalability that you need for your computing. So this is what we call the inverted C-plane architecture, where the control plane is now in the cloud instead of being in the enterprise. Okay, so let's take a little closer look at this stack. So right at the bottom over here is your enterprise infrastructure. Your control plane is now on the public cloud. The very first layer that you probably want to consider for orchestration of machine learning jobs within your enterprise infrastructure is Kubernetes. And I think there was, I think Acumos is very much aware of this and is, I think, already quite well aligned with Kubernetes. After this, you have, maybe you want to have Kubeflow extensions. And what this is going to do is it is going to allow you to deploy all kinds of frameworks on your Kubernetes infrastructure. So when we talk of frameworks, it can cover all, TensorFlow, Harvard, Beam, Keras, and so on. Then on top of this is your platform, which basically deals with model lifecycle management and deployment. Different ones here. Acumos is right over here. You have SageMaker, it's proprietary. You have TFX. They actually do provide data pipeline, different support for different pipelines. As far as I know, they do not have an open marketplace. And then you have other platforms that one could consider. And then finally, on top of this, you have the application APIs, which are basically domain-specific APIs that users who do not want to be, who do not need to know some of these details can just call some high-level APIs specific to their application. So this is kind of an architecture stack, AI stack, that one could keep in mind as you're developing your models and you're trying to use Acumos. Okay, so we looked at the complexities, we looked at the stack. I now just want to touch upon some of the pipelines that we should think about as you're developing your models. So for all the steps, right, from data ingestion to model training to model evaluation and serving, I think you kind of have 4 pipelines. You can delegate these to 4 pipelines. You have the data pipeline, then you have the MTP, model evaluation and validation pipeline, and then finally the serving pipeline. These pipelines would be very generic. Key characteristics of these are composability. That means you should be able to break this up into small components and in each of these components should be replaceable. You want to have scalability, and then you finally want to have portability, right? And each of these pipelines could be executed in a different target environment. For example, a data pipeline. A data pipeline will typically require a lot of memory, right? Because it's actually looking at data and maybe doing some transformations and so on. It could probably be run on a CPU. Whereas the model training pipeline is probably going to be computationally very intensive. And so you probably want to run it on a GPU. So basically each of these pipelines can be run on a different target environment. So now let's just briefly look at each of these pipelines, what they look like. I just want to highlight that all of these are very generic, irrespective of which framework you're using, something to really consider as you develop your models. Okay, let's start with the data pipeline. So the goal of this pipeline is as follows, right? So you're getting all this data from different system logs, different sensors, and so on. And generally, or rarely, you can just take this data and send it to your model. You need to massage this data, right? So some of the steps that are involved is, for example, data validation. And what data validation means really is that you've gotten all this data, you want to make sure that there are no anomalies in your data. So that's what you're doing with data validation. With data analysis, you're looking at the data, looking at probably some statistical distributions, trying to get insight into your data, deciding which features you want to train, you want to use for training the model. So that's your data analysis. Data transformation deals with typically, when you look at logs, everything is in strings. You probably want to map them to integers and so on. So that's what your data transformation is. So you want to take all this data that you're getting, you want to probably do some data analysis, transformation, and oops. I think I'm ready. Okay, sorry about that. Yeah, and so you essentially want to go through all these steps before feeding it to your model. The next one is the model training pipeline. So you have your data, you've gone through the necessary transformation and conversion steps. There are really three main parts over here. You have the architecture exploration. So what this really corresponds to is what kind of machine learning approach you want to use. Do you want to use neural networks, convolutional, or some other architecture? Then for a given architecture, you want to decide on the specific model instance. That is, you've trained your model. Let's say you have a deep neural network. Your model would represent the weights of your nodes of your neural network. So that's your model representation. Now, trying out different architectures, trying out different parameters for your model is very time consuming. So you want to look at, and you want to optimize both your model and your parameters. And for that, you should consider using AutoML. And I think, again, Acumos is seriously considering looking into AutoML. Okay, so and then you of course have the trainer. So you've done your model training, and so now you have your model ready for training. I'm sorry, I think I'm not going to get this till the end. I'm sorry about that. Okay, so the next pipeline that we want to consider is I'm not even touching it. What's going on? Maybe I'm just going to go back to the mouse. Okay. So yeah, so the next pipeline that we should consider is the model evaluation and validation pipeline. And the main goal of this pipeline really is to make sure that the model that you have trained is a good model, and it does not result in some kind of unexpected behavior once you have deployed it. And that's really the main goal of this model evaluation validation pipeline. It's actually a very important step because it is the gatekeeper of what model is actually going to go to the serving pipeline. The final one is the serving pipeline. So the three pipelines that you have looked at so far was the data pipeline, the model training pipeline, and the model evaluation pipeline. All of these would be in the step 2 of your Acumos, the 4 steps where you are enhancing your model, right? So that's where those pipelines would fit in. The serving pipeline would fit into step number 4, where you're trying to deploy the model. Now, when it comes to deployment of your model, these are some of the blocks that you need to consider. So you have your different models stored on in some storage. It could be S3 or it could be on some disk. The boxes with the source and the manager are essentially involved in picking up the right model and then loading it so that the model can be served. And once you have that, the serving pipeline ensures that it can serve any requests that are coming from your client or from different applications. And the preferred approach is to use gRPC, which allows you to have the client on some machine somewhere and have your server on a totally different machine. And the client can use gRPC to call all the methods of the server that is on a totally different machine. And this way it allows you to build distributed services. So yeah, so that is all I think I wanted to say about the serving pipeline. So in a nutshell, we first looked at all of the different aspects that you have to think about when you're trying to do your model, when you're trying to build your models, the AI stack, and then finally the 4 different pipelines that you need to consider. So with that, I just have a last slide. Just 3 things to remember. Most of the times, when you're serving an AI application, you need to think about the network topology. The edge is typically very important. You need to think about scale-in versus reach-in architecture. We talked about that. And then you want to think about generic pipelines and make sure that you're designing for composability, scalability, and portability. That's all I have. Any questions? Yeah. It's not part of Acumos, but I think there are some, there is. No, I'm just saying this is a general approach, right? I mean, when you want to try to come up with the best model, there are generally so many parameters that you need to figure out, and also which model you want to use. I'm just saying the AutoML approach is something that you keep in mind, whichever framework you're using. This is not specific to any Acumos or anything. All I just said was, I think I saw in one of the in the Dorias release list, AutoML as one bullet point, if I'm correct. Okay. That's something that you're looking at.
Well, again,
I think it's just discussing. It's being just discussed at this point. Yeah.
so
Just some mechanism to figure out the best parameters and model, right? That's
so one of the one aspect I think is worthwhile noting about machine learning is that it's much less deterministic in terms of the actual selection of code, right? It doesn't really matter what model you use. What matters is the results. So AutoML is a different approach to training where you're really selecting the model based on the training data set. So, we think that is really the future mechanism, but I think the point here is, instead of conceiving a single pipeline that starts with development and ends with deployment, it's very important to think about these 4 pipelines as completely separate things. You need to be able to, on a modular basis, select data, transform it, present it in a way that a particular model can use. You don't want to have to be tied then to the structure of the data in selecting that model. You want to be able to be flexible about that. And then you want to be able to evaluate the results independent of which model or what data was used.
And also these pipelines are very generic in the sense that you may want to do your data pipeline in a totally different framework, right, altogether.
I really want to point out that most practitioners, even at Google, I do that, don't do AutoML practice because it's a big Asian machinery usually. They're just trying different models, and at the end, select the best one. That's the way they work the parameter. And that's it.
Right. Well, I mean, I think of it kind of like the approach of the university to training engineers, right? You send a lot of kids to university, and then you hire a few of them when they've learned that set of skills. There's a lot of investment required in the infrastructure of an educational system to make that kind of thing possible. I think the same is true when you're training algorithms, right?
No. Just I think now AutoML has become a pretty generic term, right? Yeah.
Another question.
Yeah.
So for the data extraction phase of the pipeline, how much of it is from the existing big data technologies? Because we get, big data technologies is analyzing both structured and unstructured content, right? I would think that would be the data you need feeding to the AI system. So, are we using big data technologies for that phase?
You could, right? You could use any existing. I mean, this is just kind of, see, I think the reason why these pipelines are advocated is many times when we start working on machine learning, we just go and do some of our stuff, okay, in let's say Python, right? We develop some scripts to do data transformation and so on. And after a while, as this thing gets bigger and bigger, you just don't know how to manage it or automate it. And I think these pipelines provide you a guidance in some kind of a guidelines as to how to, in a systematic way, how to do the different aspects of machine learning so that they can be scaled, ported, and replaced. Different components can be replaced. I think that's really what I was getting at. And for let's say for the data extraction, if you want to use an existing big data framework that already does all this, so be it. Yes.
So if I can add on to that, the other point that's important to remember is that Acumos takes this approach that says, well, you, the developer, are not responsible for setting all the conditions by which your model is going to be used and deployed. So the whole idea of the community here is that people should be able to build models, distribute them into a community where others can make use of those models. And it's very important that you abstract away a lot of the mechanical part of actually making use of that model. Because if I distribute a model that can only be used with Hadoop and only be used with a certain data set, its value is really limited. So that's key to creating the kind of an ecosystem that will incent people to build models and incent other people to utilize models that have been built and distributed through the community.